welcome back. We're going to do another question because that's the best part about doing all of this. So just stick with me, okay? Here we go. Passenger plane accidents are becoming very common. In one recent accident, an Airbus with a mass of 30,000 kilograms was last seen on the radar at a height of 3,500 meters above the Earth's surface before crashing into the sea. We're not going to worry about the fact that it crashed. Okay. First question is, how does the magnitude of the force experienced by the plane compare to the force experienced by the Earth due to the plane? Even though we're talking about gravitational forces, remember Newton's third law still holds true. So yes, the plane is attracted to the Earth, but the Earth is attracted to the plane by the same amount. So that force of attraction means that it's equal to. Be careful, you are going to be very tempted to say that the Earth has a bigger force of attraction on the plane than the plane has on the Earth. That's not true. The next question is how we explain that. So now it says, explain why the plane can be seen moving towards the Earth and not vice versa. And again, you're saying, but aren't we dealing with gravity? Yes, we're dealing with gravitation, but Newton's laws all hold true. The Earth is very big. The plane is very small in comparison. They experience the same force, but because of the Earth's inertia, the Earth's not going to move towards the plane. The plane will move towards the Earth. They want to know why. So, the reason is this. The Earth has a larger mass. This means, so therefore, it has a greater inertia. That's all you need to put there. It's all about the inertia. If the Earth could be moved by all the forces it's experiencing, our Earth would not be pleasant. We'd be like, almost like ships in water. It would be very frustrating, okay? But the Earth is so big that it's not going to move towards the plane. The plane is going to go towards the Earth. Right? Okay. So, now they say, calculate the force exerted by the Earth on the plane at a height of 3,500. So, we have plane. That's my plane. I can't draw, just go with it. Okay. The distance from here to here is 3,500 meters. And they want to know the force exerted on the plane. So we want F equals, and we know it's going to be G, M for the plane, big M for the Earth, R squared. At this point, we now go, I'm missing some information. Well, maybe. What are we missing? The Earth's mass, the Earth's radius. Do I expect that you know them off by heart? No. It's on your information sheet. That's the important thing. Okay, it's on your information sheet. So, the radius of the Earth, is, I'm looking it up, just go with it. Okay. Oh. Okay, so I'm only going to get this far, actually. 5 minutes, hang on, wait. Yeah, because I've got another question after this anyway. Yeah, it's... Yeah, no, I will, don't worry. Okay, so can I be turning to the board saying the radius of the Earth is? Oh. Okay. Yes?
Okay, what's going to happen now? After writing, what are you going to do?
I've got to finish the answer to this question.
And the paper, what are you going to do?
Oh no, I'm just going to put it. I just need to remember the numbers.
You can write it down and
Then I'm going to throw it on the floor.
no pause,
Yes?
and then do whatever you need to do, compose yourself, and then start again.
Okay, I'll just.
Don't feel rushed.
Okay.
As long as there is that pause, then they will cut out the...
The me moving the paper.
Yeah.
Got it. And don't talk during the pause.
Exactly.
Silence is golden, don't be silly. Anyway. Yeah.
And 3, 2, 1.
So, the radius of the Earth, which you will look up on your information sheet, is 6,4. Let's try, times 10 to the 6 meters. Yes, we do need to do, because that was pathetic.
Okay, cool. And you're just doing the...
Yes, the radius of the Earth.
Cool. You ready?
Yep.
And 3, 2, 1.
So the radius of the Earth is 6,4 times 10 to the 6 meters, and we find that on our information sheets. And the mass of the Earth is 6 times 10 to the 24 kilograms. You don't need to know either of those values. Like I've said, they're on your information sheet. Now I have enough information to complete my question, except for one thing. The 6,04 is the radius of the Earth. So it's this little distance here. I need to know the total distance for putting it into the equation. I'm going to need to add 3,500 to it. Here we're going to put it into the calculation. Watch. 6,67 times 10 to the minus 11. The plane was 30,000 kilograms. The Earth is 6 times 10 to the 24. And my distance is the Earth's radius, 6,4 times 10 to the 6, plus the 3,500 meters it is above it. If you want to do the calculation of R separately, so put it into your calculators, do it separately, you're welcome to do that. That's not a problem. Okay, I'm just doing it all in one step. Need our calculators. So let's see what we get. I'm going to do the top, which is 6.67 to the minus 11 times 30,000 times 6 to the exponent 24. And it's a big number. It's a very big number. But now I'm going to take that answer. I'm going to divide it by, now watch, I'm going to put this in brackets, 6.4 to the 6 plus 3,500, close my bracket, and then square it. And I get 292,794. We don't like numbers like this. Let's put it into scientific notation. So there we go, always to 2 decimal places. And it's 2,93 times 10 to the, I think it was to the 5. Let's just check. There we go. All right. It's quite big. I'm okay with that. It was a very big mass, but what's the direction? Calculate the force exerted by the Earth. It experiences a force down. I don't say attraction now because it's Earth on plane. Plane comes down. Okay, we've tackled some difficult questions, and that's where we're going to end for today. So I'll see you again next time.